Hi, it's Mr. Bletch here. We're looking at nth term of an arithmetic sequence. So an arithmetic sequence of numbers is a set of numbers that are increasing linked to a times table or decreasing linked to a times table. And the terms just relate to the numbers. So this is the first term 5, the second term 8, the third term 11. And the n bit is just that again. So for 5, that is n is 1, as in 5 is the first number. 8 is n is 2, the second number in the sequence. This is n is 3, where 11 is the third number in the sequence. So what we're asked to find here is find the nth term in the sequence. And what that means is find a rule for figuring out what's going on with the numbers. So let's figure out what the times table is that we're linked to. So we go from 5 to 8. That's going to be plus 3, isn't it? And we go from 8 to 11. That's going to be plus 3 again. And we find that we're always linked to the 3 times table. So if we have a think then about that, the first number in the 3 times table is 3. How would we go from 3 to 5? Well, we would add 2, wouldn't we? So if we want the nth term rule, we know we're linked to the 3 times table. That's going to give us 3n. And then to make it work properly, we need to add the 2. Okay, so that's your nth term rule for the sequence. Now, the nth term rule can be used to find any number in the sequence. So rather than, for us to find the 100th term, rather than writing out 100 times all the way over the paper and filling the paper up, we can use the rule to do that. A little bit of substitution. So what we're going to do is we're going to say, well, what we had was 3, and touching means timesing, so that means times, and the n number, this is the n number here, right? That's the n number. So what I need to do is multiply by 100. Okay, and then we needed to add the 2, don't forget that. So this is basically the rule. So the 3 comes from the 3 there. The n number was whatever term we're asked to find, and we don't forget the extra bit. So that is just going to be 302. Now, is 101 in the sequence? It's slightly more complicated. So what I want to do is write down what the rule is. So if the rule is 3n plus 2, the question I'm asking is, with the rule, can I make the number 101? So I put like a question mark above the equal sign there. Then we'll do a little bit of algebra to go figure that out. So it's like rearranging equations. So we're doing the opposite of all the operations, trying to unstick all the numbers away from the n. So the number that's least stuck to the n is the 2. So it says plus 2, we'll do minus 2. So if we're going to add 2 and take 2 away, that's like, adding 0. So we haven't got that anymore. So that's just 3, wrong colour pen, 3n is maybe equal to 101 take away 2 is 99. And then because we've got touching means timesing, this is 3 times n. Do the opposite of timesing by 3, which is dividing by 3. So we're going to end up with, well, 3 divided by 3 is like 1, but because it's algebra it's invisible, so 1n equals question mark, and 99 divided by 3 is 33. Okay. Now the issue here becomes, because n is a whole number, (101) is in the sequence. and this is the 33rd term, or 33rd number. And we're done. Okay, so on example 2 now. So we've got to find the nth term in this sequence. And if we look at the numbers 9, 7, 5, 3, the numbers are clearly going down this time, right? So what are they going down by? They're going down by -2 each time. So this is telling us we're linked to the -2 times table. And then if we think, what's the first number in the -2 times table? That's -2. How do we get from -2 to 9? I add 11. So there's kind of two ways you can end up writing this. So the sort of straightforward way, and that is perfectly correct, would be -2n add 11, and that is just fine. Sometimes over in the exam questions you see it written the other way around, but because this is adding, we can swap the two terms around. So if you think about numbers on their own, like 3 plus 5 is 8, and 5 plus 3 is 8, so you can have the numbers different ways around and you get the same answer. So because this is adding, I can swap them around. So this is going to be 11. Now when I swap them round, I'm going to get 11 add -2. When I've got an add and a subtract together, then the overall effect is a subtract. So I'm going to get 11 minus 2n. Okay, both correct. You just need to be aware that you can see them both ways around. So find the 50th term. So like before, the 50 bit is your n number. So what we're looking to do here is we've got 11 and we're taking away 2 times your n number, and your n number is 50. So that's going to be 11 take away 100, which is equal to -89. Okay. And is -23 in the sequence? So like before, we need to sort of write ourselves out a little bit of an equation. So we've got our rule, and our rule was 11 take away 2n, and then we just need to question mark whether that's going to be equal to -23. A little bit more complicated here because of all these negatives, but we need to get the n on its own, so let's get rid of that positive 11. So that means we need to do -11 to both sides. So 11 take away 11, that just goes away, so now I've got -2n. Is that equal to, now -23 take away another 11 is going to be -34. So now we need to do the opposite of multiplying by -2, which is dividing by -2. So how many -2's in a -2? There's like 1, so that's an invisible 1 because it's algebra. Is that equal to -34 divided by -2? So negative divided by negative is a positive. So that's going to be 15, that's going to be 17. Okay. So the answer is going to be yes, -23 is in the sequence. N is a whole number. Because n is a whole number, then it's definitely in the sequence, and it's going to be the 17th term, or the 17th number in the sequence. Okay, and we're done. Okay, so we're on example 3. So we've got to find the nth term for this sequence, and a little bit complicated, I guess, because we're starting with negative numbers, but the negative numbers are definitely getting bigger each time. So minus 19 to minus 15, they're definitely getting bigger, and they are in the 4 times table, so we're adding 4 each time. So what's the first number in our 4 times table? It's 4. So how are we getting from 4 to negative 19? We're having to take away 23 each time. So what's our rule? Well, that's going to give me 4n. So my overall rule is 4n, and I'm going to take away 23. So that allows me to find any old number in the sequence now. So now we need to find the 12th term. So remember, the 12th term just means that's my n number. So I use my rule. So I've got 4, and touching means timesing, so 4 times n. Well, I know what n is. N was 12. And I needed to subtract my 23. So that's what I needed to do. Well, that's going to give me, what, 48 take away 23. Well, 48 take away 23 is going to equal 25, isn't it? So there's your 12th term. Now we need to answer whether 32 is in the sequence. So like before, write ourselves down a little sort of equation. So 4n take away 23 equals question mark 32. Let's see if this will work. So if it says take away 23, we need to do the opposite. We need to do it to both sides, just like solving equations. So if we're going to take away 23 and add 23, that kind of goes away. It's like adding 0. So we're just going to be left with 4n equals question mark. That's going to be 55, isn't it? Now we need to do the divided by 4 bit, alright? So that would give me n, will give me 1n, I guess. So I only need to do a little bit of bus stop here. So I need to do 55, and I want to divide it by 4. So 4's into 5, that's 1 with 1 spare. 4's into 15 is going to be 3, and I'm going to, so that'd be 4 times 3 would be 12. If I count on 12, 13, 14, 15, I've got a remainder of 3, haven't I? So it's not a whole number. I mean, I could go into the decimals, right, but we don't really need to. So what we need to say is, no, 32 is not in the sequence. As n is not a whole number. So we could go on to say a little bit more about that. So if we look at our bus stop, so 32 lies between, so it's going to lie between the 13th term and the 14th term, isn't it? Okay, and we're definitely done now. Okay.